Welcome. This deep dive is, well, it's tailor-made for you. The developer, the solopreneur, the architect, who's really determined to build systems that scale automatically.
Right, not just selling your time for billable service.
Exactly. We want to build systems, not services.
And today we are cracking open a set of blueprints for doing just that. We're looking inside a really anticipated, still unreleased guide, boring problems, big money.
And we have to say, before we go any further, a huge thank you to the ex-freelancer for granting us this unique pre-launch access. It's incredible.
It really is a profound thank you.
So our mission today is foundational. I'd even say it's surgical. We're going to isolate and decouple your application's architecture from its single most expensive, riskiest,
And most common point of failure.
right, identity management. We're diving deep into a concept called identity inheritance.
And we're going to understand how within certain ecosystems it lets you just skip the worst part of software development entirely.
Okay, let's unpack the pain first, because I think every single person listening has felt this.
Oh, for sure.
The core failure point for most solo developers, and I mean even a lot of bootstrap teams,
Yeah.
it's not that their idea is weak.
No, it's not the code either. Not usually.
It's the security infrastructure. The stuff you need just to prove a user is who they say they are. It's this inescapable, complex, just crushing overhead of custom authentication.
The book frames this perfectly. It basically says, stop acting like a laborer.
Stop writing custom login screens.
Exactly. You are an architect. You should be designing systems for leverage. But just think about the hidden costs for a second. Why would you, with your, finite high-value intelligence, waste weeks,
Or months.
often months, trying to solve problems that are already solved at a multi-billion-dollar scale?
We're talking about the trifecta of terror here. Storing encrypted passwords safely, handling all the account reset workflows, managing that incredibly complex token expiration lifecycle.
And mitigating the constant, relentless brute force attacks that will come.
Oh, and then there's the joy of trying to implement and debug a two-factor authentication system that actually works across, 5 different devices a user might have?
That manual effort, building that security gate from scratch, even if you're using modern serverless tools, it's an operational black hole.
It creates what the book calls infrastructure drag.
And for a solo operator, that drag, it immediately eliminates your profit margin before you've even shipped a single feature that makes you money.
Chapter 3 of the book estimates that for a typical micro SaaS on a standard cloud stack, maintaining a compliant, secure, custom identity system, it accounts for 30% of long-term OpEx.
And that's excluding the initial build cost.
30%. That's staggering.
It is.
It means 1/3 of your recurring monthly bill and, a third of your precious debugging time is going toward a feature, a login screen that provides zero unique value.
The user just expects it to be there and to be secure. They don't pay you extra for it.
They only notice it and penalize you when it fails.
And that is the trap. The book is explicit here. Every moment you spend debugging a forgotten session token or, a multi-factor enrollment failure,
That's a moment you are not building the core logic.
the solution to the boring problem that people will actually pay you for, you are, in effect, volunteering to shoulder this massive legal compliance and tech liability of being a global identity provider.
And let's not even get started on the compliance nightmare.
Oh, please.
If you store sensitive information, even hashed passwords, you suddenly fall into the scope of GDPR, IPA, CCPA, depending on your user base.
So your little $9 a month side project now needs lawyers and security audits.
Exactly. The risk profile is immediate, and it's catastrophic.
And this is where identity inheritance just flips the whole architectural burden on its head.
Now so.
It acknowledges that identity verification is a commoditized, solved problem. And for the systems we're talking about, these high-leverage automation systems, the smart move is to offload the entire liability.
So we're not just talking about saving a few hours writing some login code.
Not at all. We are talking about fundamentally altering the risk profile and the total cost of ownership of your application. And by doing that, you safeguard your profit margin.
Okay, so that brings us to the core technical solution. This is from Chapter 9, right?
Yes, identity inheritance. The strategic mandate is, it's to outsource this entire massive security liability to the Google ecosystem.
Specifically by leveraging its native architecture, like Google Apps Script.
Right. And the aha moment here isn't just knowing, oh, I can use Google Sign-In.
No, it's deeper than that.
It's realizing that Google Apps Script, by its very design, structurally eliminates the need to build a login screen. because that initial identity validation is already done.
You mean authentication or authena?
Precisely.
Huh.
It's performed the moment the user is signed into their Google account and tries to run your script.
We should probably delineate those two concepts, authn and authc. I think that's critical for our audience.
Good point. Identity inheritance handles the authn, proving who the user is automatically. Flawlessly.
Which frees you, the developer, to focus only on authz.
Authorization. Proving what the user is allowed to do inside your application, based on their subscription tier or their role.
That clarity is vital. So I'm building a service. I don't need to ask for their name and password.
Because Google has already handled that.
I just need to check if they're a paid user in my system.
Exactly. Identity inheritance is the act of leveraging Google's native oath tokens to automatically verify users.
Let's use that keyring analogy from the book. I think it's a good one.
Okay, so think of the user's Google account as a massive, heavily fortified digital keyring.
Secured by Google's best engineers, 24/7.
Right. And when a user installs your add-on or runs your script, and they click that critical allow button on the authorization screen,
That white pop-up everyone knows.
they are not handing over their entire keyring.
That's the key misconception.
It is. They are granting specific, highly constrained security badges.
Technically, these are scopes, right?
Yes, packaged inside encrypted oath tokens. These tokens are cryptographically signed by Google's authorization server. They only authorize access to the specific services your app needs to function. Nothing more.
Okay, let's walk through the techno workflow. For the architects listening, this is where the rubber meets the road.
Sure.
What kinds of tokens are we talking about, and why does this process eliminate the developer's burden of managing them?
So in the standard OAuth 2.0 flow, which is what underpins all of this, there are typically 3 crucial components. But as the developer, you really only deal with one, and even then, it's implicit.
Okay, what are they?
First, you have ID tokens. These prove the user's identity. That's the authn part. Google handles issuing and verifying these completely.
Got it.
Second, access tokens. These are short-lived credentials, usually good for an hour or less. They grant permission to call specific Google APIs, like sending an email or reading a sheet.
And Google Apps Script just handles that for you.
It handles the storage and presentation of these tokens when your script runs. You don't see it.
Okay, so what's the third?
Refresh tokens. This is the game changer.
The refresh token. The sleeping dragon of security liability.
That's a good way to put it. This is a long-lived, highly sensitive token that allows the platform, in this case GAS, to request a new access token after the old one expires.
And it does this without forcing the user to log in again.
Correct. And if that token is stolen or mishandled in a custom system, it can grant perpetual access. It's where most custom identity implementations fail catastrophically.
And that is the critical insight from the book. When you build a custom system, you are responsible for securely storing, encrypting, rotating, and revoking that refresh token.
You become the target.
With identity inheritance, the Google platform handles that entire lifecycle.
The app script environment securely stores it. It manages the exchange using sophisticated flows, things like PKCE. It silently rotates it. You, the developer, never touch it.
You never store it in your database.
And thus, you never assume the liability.
So the result is pure leverage. The script runs as the user with their confirmed identity, and the platform manages this whole multi-million-dollar security infrastructure.
Token management, expiration, rotation, revocation.
For free. You're basically renting Google's dedicated security team.
That's it. This lets a solo architect achieve instant enterprise-grade security and compliance without writing a single line of password management code.
The security risk isn't gone, it's
entirely outsourced to the one entity that is structurally capable of handling it at a global scale.
Which brings us to the specifics. The scopes, or the security badges as we call them.
Right. This is where the architect gains granular control over the authorization part of the contract.
And this isn't just about security, is it? It's about marketing. It's about user conversion.
Absolutely. Your scope selection is your secret weapon for minimizing what the book calls permission friction.
Explain that.
When a user sees that authorization screen, they're doing an immediate subconscious risk assessment. If you ask for too much, they're gone. They just walk away.
So if you request the broadest possible scope, say Drive, which is see, edit, create, and delete all of your Google Drive files,
your conversion rate just plummets. It doesn't matter how good your product is. The ask is too big.
I remember debugging a custom auth flow years ago. I spent 2 straight days on one bug.
What was it?
Sessions were timing out unpredictably. It was a single line of code in the token expiration logic that I had misread. It was just soul-crushing.
Ugh, I can imagine.
The idea that a platform handles all of that dynamically and all I need to worry about are the scopes, that's genuinely liberating.
It is, and the book stresses that great architects request minimum viable scopes.
Let's look at some examples from the book. I think it lays out a few project archetypes.
It does. Let's start with the lowest friction. Scenario A, the core utility. Let's say an inventory tracker.
Okay, so a niche add-on runs only inside one specific Google sheet, tracks inventory, calculates sales tax, that sort of thing.
What scope do you need?
You'd request the most constrained one you can.
Yeah.
Spreadsheets.currently.
And this is so crucial for trust. It's the lowest friction scope because the user knows explicitly that your script's access is limited only to the spreadsheet it's currently running in.
So you can't read their whole Google Drive.
Can't send emails, can't even read other sheets they own. It's a clean, tight contract. The user approves that almost without thinking.
So the platform itself is enforcing a trust boundary. That is huge for conversion rates.
Okay, let's step it up. Scenario B, the high-value asset. The classic micro SaaS project, an AI email automator.
Right, so it needs to read data from a sheet and then send personalized emails based on that data.
What's the scope here?
Well, you have to ask for gmail.send. No way around it.
And this is a higher friction scope. Sending email on the user's behalf is a powerful permission.
But the value proposition saving them hours of manual work through AI, it justifies the ask.
Exactly. Google checks the badge, confirms the user is valid through identity inheritance, and authorizes the script to send that email. The authentication is invisible, but the authorization is explicit.
Okay, now for the really complex scenario, say I'm building a powerful tool like a document management system. It needs to scan all files in a specific folder in their drive and modify them.
That's going to require a sensitive, broad scope, probably Drive.
And what does the book say about that?
It cautions against this unless the value you're providing is absolutely astronomical. Because that's such a broad ask, Google will typically force that app through a pretty rigorous security verification process.
So the friction skyrockets. You have to prove to Google why you need that access.
And the cost of acquisition, just in terms of user trust and your own time spent on verification, it often outweighs the revenue for a solo op.
So the lesson isn't just use scopes, it's design your entire application to demand the smallest possible scope.
That's the architectural mandate. If you can use currently instead of Drive, you've just significantly reduced your business risk and friction.
Let's compare this to the alternatives for a second. Let's say you skipped identity inheritance.
Yeah.
You opt for a serverless identity provider like AWS Cognito or Auth0.
Both powerful tools. But the total cost of ownership is immediately higher. You have subscription fees, usage fees.
And you still have the maintenance of connecting that provider to your core logic.
And critically, you still have the responsibility of maintaining your own user database, of handling the federated identities and running your own internal auth-z checks.
Identity inheritance just collapses that cost model.
It does. You get enterprise-grade auth-in, token management, and a robust auth-z framework with scopes for the near-zero overhead of the app's script ecosystem.
This is how the architect maximizes leverage.
And achieves sovereignty by eliminating these necessary but non-differentiated components that plague traditional development. The book argues pretty persuasively that this one architectural choice is the difference between a sustainable automated income stream and an unsustainable service-based job.
So, if the technical setup for identity is now a solved outsourced problem, what does that free up the architect to actually build? What's the strategic takeaway?
The mandate is singular, focused entirely on your solution's core logic.
The boring problem.
The boring problem that people will gladly pay you to solve. Identity inheritance eliminates the single most difficult, risky, and time-consuming part of commercial software development, period.
So as we've established, authentication is just an outsourced utility in this ecosystem. The smart architect stops building the security wall.
And directs all of their intelligence, all of their creativity toward the actual solution that provides value.
The leverage here is immense. When you build within this ecosystem, your app inherits the security posture, the uptime, the regulatory compliance of a trillion-dollar company.
Right. And the traditional fear of relying on a third party for identity is minimized because, Google's stability is arguably the highest in the world. This isn't just trading one single point of failure for another.
You're leveraging a foundational utility.
Exactly.
I think we need to reiterate that shift from OpEx to utility as a service.
Please do. It's a critical point.
In a traditional model, identity management is an operational expense, OpEx. Money spent on servers, maintenance, security patches.
In the identity inheritance model, it is purely a platform utility, a feature of the ecosystem you've chosen to build in.
And that shift is why this is so profitable for a solopreneur.
Every unit of time and cost saved on Authn can be redirected to features or to marketing or, critically, to rest and recovery. The goal of the book is sovereignty.
And sovereignty means achieving income without constant, non-differentiated labor.
We also can't forget the simplicity this brings to the user experience. Since the authn is handled by the platform, the user never even sees a login form.
The entire security boundary is managed by that single familiar allow prompt,
which minimizes friction at that critical onboarding moment.
So when you're building your next app's script utility, the final actionable advice is simple.
Architect for leverage, not for labor. Design your application's functionality around the smallest possible scope requirements. Let the platform enforce the identity checks, handle the token lifecycle, and secure the keys.
And focus your intelligence where it actually generates revenue.
Solving the specific problem, delivering the utility, and then managing the internal authorization logic. The simple database check that separates your paying customers from your free users.
By inheriting identity, you are not just getting a free login screen.
You are acquiring a fully maintained, globally distributed security team, and you are removing the #1 reason why independent software projects fail.
Which is operational and compliance burnout.
Exactly.
And that brings us to the end of this deep dive. The core lesson here, based on the blueprint from the ex-freelancer, is recognizing that the biggest architectural risk is often the one you choose to build yourself, unnecessarily.
If a trillion-dollar company is offering to take on your worst liability for free,
the strategic architect accepts that offer immediately.
So the question for you to mull over until our next deep dive is this. If you could audit the last 5 security vulnerabilities you patched in your past projects, how many of those were directly related to identity management?
And how much financial, emotional, and time-based capital did outsourcing that problem today just save you? Think about the immediate return on that non-investment.